Hello everyone, my name is Avan Kumar from marinerspro.com. So today in this video we are going to talk about important technical questions that were asked in previous year in Synergy exam for the TME or engine cadet. So this is basically a revision video where I'll be sharing different questions from the multiple domains. So let's start with the first is these are the important topics which you need to focus on because this has been asked in the Synergy exam repeatedly. The first is the thermodynamic cycle. So we have the three thermodynamic cycle, that is diesel cycle, Otto cycle, and the dual cycle. So you can see the PV diagram. So in this diesel cycle, so diesel cycle is also known as the constant pressure cycle. Otto cycle is the constant volume cycle. So here you can see in the PV diagram. So from 1 to 2 it is isentropic compression. Then 2 to 3 is the constant pressure heat addition. Then 3 to 4 is the isentropic expansion, and then 4 to 1 is the constant volume heat rejection. Similarly, it is 1 to 2 is isentropic compression, then 2 to 3 is heat addition but at constant volume, then 3 to 4 heat then 3 to 4 is isentropic expansion, then 4 to 1 is heat rejection at constant volume. And in dual cycle it is mixture of diesel cycle and Otto cycle, or we can say it is both the constant pressure and constant volume. So here you see that from 1 to 2 it is compression, then 2 to 3 this is constant volume heat addition. So here heat is added at a constant volume. Then 3 to 4 it is constant pressure heat addition, and that is heat is added at a constant pressure. Then 4 to 5 that is the expansion, then 5 to 1 is heat rejection. Next is these are the four laws. So in some of the years Synergy has asked in laws like water laws and determine the volume and temperature relation. So these are the first is Charles law, so it determines the relation between volume and temperature. Then the second is Gay-Lussac's law, that is and that determines the relation between pressure and temperature. And then the third is Avogadro's law, that determines the relation between volume and moles. And then the fourth is Boyle's law, that determines the relation between pressure and volume. So I have given the definitions of all these four laws, so you can read it once, so that to get the enough clarification, so that to retain it in the exam. So just go through this definition. The first is Charles law, then Gay-Lussac's law, then Avogadro's law, and then Boyle's law. So next we have stress strain curve. So this is also an important topic. So this has been asked multiple times. So this is a stress strain curve. So here different points are given. So you just have to remember which points are, where is the elastic limit, where is the plastic limit. So where is this ultimate strength. This is like here point D is the ultimate strength, the fracture point or the breaking point is point E. So you have to remember this diagram as well. Next is important topic is types of rudders. So this has been also asked in Synergy exam multiple times. So in that we have the balanced, unbalanced, and semi-balanced type of rudders. So basically these balanced, unbalanced, and semi-balanced are designed or defined based on the position of rudder with respect to the rudder stroke. So here in this figure you can see this is the rudder stroke and this is the rudder. So based on the relative positions we determine whether the rudder is balanced, unbalanced, or semi-balanced. So in case of balance, there is some portion of rudder that is beside the rudder stroke, and maximum of the portion is outside the rudder stroke. And in case of semi-balanced, in case of unbalanced, if you see all of the portion of rudder stroke is inside of the rudder. And in case of semi-balanced, it is mixture of balanced and unbalanced. Half portion is up to half portion we see that it is working as a semi-balanced, and the next half it is working as a balanced. And if this is just a diagrammatical representation to understand and give you a pictorial view, or in the simple thing you can understand from this diagram that this is the rudder stock. So if the rudder stock is like this, and some portion, this is the rudder, so some portion of rudder is on the left side on one side and maximum portion is on the other side, then in that case it is a balanced rudder. If the rudder stock is on one side and the rudder is completely on the other side, then that will be unbalanced. And if it is a mixture, like half portion is up to half portion we are seeing the rudder, and then here in the next half we are seeing the full case, that will be semi balanced. It will be mixture of balanced and unbalanced. Next is ship's stability and equilibrium. So this these questions has been also asked, whether the how the ship when in what condition the ship is stable or not. So here the GM represents the metacentric height. So when the GM is greater than 0, that is metacentric height is greater than 0, that then the ship is said to be have a positive stability. When the GM is 0, then it is said to have neutral stability or in a neutral position. And if the GM is less than 0, then it ship is said to have negative stability. Or if we say in here you can say in the diagram, the G is that the center of gravity and M is the meta center. So when in case of stable equilibrium, the center of gravity lies below the meta center, and in case of neutral equilibrium the meta center and center of gravity coincides with each other. In unstable equilibrium the center of gravity is lying above the meta center. So that will be in unstable equilibrium. So next we have the ship's motion. So this is like pitching, rolling, yawing, swaying, etc. So this is a small video, you can just go through it and just understand what are the different terms like pitching, rolling. So with this pictorial, with this video, you will be able to understand along which axis it is pitching or rolling. So the first case is pitching. This is rolling. Then this is yawing. Then this is heaving. Ship is moving up and down. Then this is swaying. The ship is having a lateral movement of right to left. And then this is surging. So ship is moving backward and forward. So these were the ship's motion. So here this is a recap. You can go through this. Like in pitching, we have the ships rotate along the transverse axis, that is up and down, and the movement will be in the aft side and peak side. Then the second is rolling, so it revolves around longitudinal axis. So in this list occurs and the movement will be left and right. And third is yawing, so it is across the vertical axis. So this is cross dance, like the ship is moving like this or this. Then this is heaving. Next is heaving up here, and the ship is moving up and down. And then the fifth is swaying, so the ship is moving side by side. And then the sixth is surging, so ship is moving forward and backward. Next is the pump characteristics curve. So this has been also repeatedly asked, so you just have to go through this diagram. So this is like the capacity, and here is the head of the pump. So this is the graph for the efficiency, this is for the brake power, this is for the head of the pump, and here this is the point of best efficiency point, or we can say the maximum efficiency of the pump. So just go through this diagram and remember this, because based on this other questions can be asked, like what is the, like it can be asked like it will give like this, what is this line represents, or what this line represents, something like that, or where is the point of maximum efficiency. Then next we have the heat treatment process. So some of the questions has been asked from the heat treatment process also. So we have annealing. So first heat treatment is annealing. So annealing uh, is mostly used for the iron and steel, and it is heat in this case the heating is done up to 30 to 50 degrees Celsius above the critical temperature, and the cooling is done at a very slow rate. So this is the main aim of the annealing is to make steel more ductile. This is an important point. The main aim is to mm, make the steel more ductile and malleable. Just go through this slide. Then the next is normalizing. So in case of normalizing, is this is mainly, this is also done 30 to 50 degrees Celsius above its critical temperature, and in this case the cooling is done in air, and this normalizing improves the machinability and the tensile strength. Next is hardening. So you can go through this slide. Then we have the tempering. So tempering all results in reduction of brittleness and removal of the internal strains. You can go through the other purposes as well. Next we have the classification of fire. So we have four types of fire: class A, class B, class C, and class D. So class A is solid materials such as wood or paper, so general materials. Class B is liquids or non-flammable liquids or gas such as alcohol, ether, gasoline. And then class C energized electrical fire. Then class D is metallic substances such as sodium, titanium, zirconium, magnesium, etc. And this is the table where you can see what type of fire extinguisher we can use to extinguish what kind of fire. So just go through these tables. These kind of questions can be asked and has been asked in the synergy exam. Next is some important questions that has been asked in synergy. So the first is the suction force principle is a typical characteristics of, so this is a characteristics of a reciprocating pump. Then if the cooling water flow through an aftercooler is interrupted, the power output of the turbocharged diesel engine will drop because if the flow is interrupted, then the density of charge air cooler will decrease. Next is the purpose of an intercooler installed on a high pressure starting air compressor is, so we know that to absorb the heat of compression in the air charge formed in the first stage. So after first stage of compression there is heat generated. So in that the intercooler is there so that this heat can be reduced. Then fuel oil penetration into the cylinder of a diesel engine is reduced by the final automation. The next is the product of piston area, piston stroke, and the number of cylinder gives the displacement of an engine. So many people might make mistake here, like here the total cylinder volume or some other thing. So just pay attention. This is the displacement. Then which condition will cause a running auxiliary engine to automatically shut down? So it is the low lubal pressure which will automatically shut down the running auxiliary engine. Then the bottom part of a bowl assembly in a centrifuge or the purifier is kept closed during operation by, so the operating water The operating water is used to maintain the centrifugal pump, the centrifugal or the purifier in a closed condition. So this answer is operating water pressure. Next is the amount of fuel delivered by a helical plunger type fuel injector pump is controlled by, so it is by the rotation of the pump plunger. So if you have seen the previous video in which I have given the diagram of the fuel injector, so there also I have discussed how the quantity of fuel is controlled in helical plunger type fuel injector. Next is the refrigerant entering a compressor should be in. So when the refrigerant is entering the compressor, it should be in the form of superheated vapor. Next, in reference to the air conditioning, when air attains maximum amount of moisture, it can hold at a specific temperature. It is said to be. So when the air attains a maximum amount of moisture, so at a specific temperature, it is said to be saturated, which means at this after this saturation point, the air can hold no moisture. Next is the pyrometer is used to measure the exhaust gas temperature. Then this is for how much consecutive start is needed by the air bottle. So the air starting system, for in case of reversible engine, the air starting system should be kept in such a way that it should be capable of 12 consecutive start, and in case of irreversible engine, it should be capable of 6 consecutive start. Next is in a running refrigeration system, which condition can cause low compressor discharge pressure? So low compressor discharge pressure can be caused because of the air in the refrigeration system. Then when metal is tempered, it becomes, so as discussed earlier, so tempering is done to make the metal less brittle. Now coming to some numerical parts asked in the synergy exam. The first is a calibration gas bottle containing propane has a pressure gauge fitted to it. The pressure reading is 11 kg per centimeter square. So what is the absolute pressure of the propane? So the formula for absolute pressure is atmospheric pressure plus gauge pressure. So we have given this atmospheric pressure is 1.03 kg per centimeter square, and the gauge pressure here it is given 11 kg per centimeter square. So total will be 12.03. Just remember this formula. Next is a turbo generator has a rated output of 1200 kilowatt at 60 Hz with no load frequency of 61.5 Hz. What is its speed drop? So here we have to calculate the speed drop. The formula for speed drop is speed at no load minus speed at full load by speed at no load. And since n is equal to 120 f by p, here it is f is the frequency and p is the number of poles. So if this p is constant for a particular turbo generator and 120 is also constant, so n is directly proportional to frequency. So this is formula can be deduced to frequency at no load minus frequency at full load by frequency at no load. So this will be the formula for speed drop in case of RPM and in case of frequency. So here we see we are given the frequency. We can directly use the formula frequency at no load, which is given at 61.5 Hz, and frequency at full load, which is given at 60 Hz. So 61.5 minus 60 by 61.5. So it will come to, and if it is asking for the percentage, so it will be 2 point multiply it by 100 and it will come to 2.44%. Next is a YouTube manometer filled with fresh water shows a reading of 800 millimeter water column. So the approx pressure in the bar would be. So here basically we have to convert this 800 millimeter column of water to uh, bar. So the table it is, so the conversion point is given here. Just remember it. 1 millimeter of H2O is 9.81 Pascal and 1 Pascal is 10 to the power minus 5 bar. So here actually this is wrong. This is wrong. It should be 0.08. because it is saying approximately, so it will be 0.08 because 800 millimeter of water, and this is multiplied by approximately 10, so it will be 1000, and if you this is 10 to the minus 5, so it will be 0.08 bar. Next, what will be the diameter of a cylinder with a cross-sectional area of 706.86 square meter? So this is very basic. So uh, using the using the formula of area of cylinder, that is pi r square. So cross-sectional area, it is given 706.86 square. So you can directly calculate the r and then d. Next is the power supply to a motor is 6 kilowatt at 120 volt. So what is the impedance of the motor? So the formula for impedance is in the next slide. So here you see the formula for impedance is Z is equal to root under R square plus XL minus XC square, where XL is the inductive reactance and XC is the capacitive reactance. But here in this question you can see only resistance is given. Uh, you can see there is no mention of inductive reactance or capacitive reactance, which means this is a resistive circuit. So therefore we can directly use the formula of P is equal to V square by R. So in resistive circuit we know the formula for power is V square by R. So from here we can find the resistance, and that resistance will be equal to the impedance. So just remember this formula, that is the formula for impedance is root under R square plus XL minus XC square. And how can we find the inductive reactance? So it is 2 pi f into L, where L is the inductance of the coil and 2 pi f is equal to omega, that is angular velocity. And capacitive reactance we can find by 1 by 2 pi f c, where c is the capacitance in farads. Just remember this formula. So if any other question is asked based on this formula, you can directly apply it. Next question is, the capacity of a fuel oil transfer pump is 100 cubic per hour. If a fuel oil settling tank measure 10 meter, breadth is 10 meter and height is 6 meter, how long must be the pump run to fill the tank to 5-meter height, considering the tank presently holds fuel to 2-meter sounding? So here it is saying 2-meter sounding, which means the tank is already full to 2 meter, and now the total is 5, so this remaining height is 3 meter only. So we have to so this height is 6 meter, height is here given 6 meter, but we have to fill the tank up to 5 meter height, and it is previously filled up to 2 meter. So we just have to fill 3 meter more. So our effective height will be 3 meter. We'll just it is a volume, and by the capacity we can find the required time. Next is a 4-pole 3-phase 60 hertz synchronous motor comes up to 1760 rpm. When started as an induction motor, what is the percentage slip after the rotor field is energized? So the formula for percentage slip is same like speed at no load minus speed at full load by speed at no load. And coming to the question, we see that this is given at 60 hertz 1760 rpm. So this is given at a load, right? So but we have to find first speed at no load. So we have the formula n is equal to 120 f by p. So with using this we can find the uh, speed at no load. So 120 into f, that is frequency, is 60, and p, the number of pole, is 4. It comes to 1800. So this is the speed at no load, and then the rest is simply calculation, so you can calculate. The next question is, a load is connected across the secondary of a step-up power transformer, and the current drawn by the load is 10 ampere. If the transformer has a turn ratio of 1 to 10 and the input voltage to the primary is 110 volt, what will be the current flowing through the primary? So here basically we have to find the current flowing through the primary. So we have this formula like V into I for the primary is equal to V into I for the secondary circuit in the transformer. So here what you see, mm, voltage in primary. So the first voltage in primary it is given. So we have voltage in primary. Then current in primary we have to find out. Then voltage in secondary. So voltage in secondary is not given. And then current in secondary. So current in secondary stepper transformer is 10 ampere. So current in secondary is given. Now we have to find the voltage in secondary circuit. So for that we can use the formula number of turns in secondary ratio is given of the number of turns in secondary to the primary is 10 is to 1. So with this number of ratio of turns and the ratio of voltage is this one. So number of turns in secondary to the primary is equal to number of voltage in secondary to primary. So with this formula we can find the value of voltage in secondary, and then we can just simply put the value of secondary and we can find the value of the current in the primary circuit. So next is a liquid has a specific gravity of 0.9960 at 15 degrees Celsius. Its density at the same temperature will be. So that we have to find the density. So for that we have the formula specific gravity is equal to density of the substance by density of the water at 4 degrees Celsius, because this is at the maximum density of water. Using that we can find, this is just a simply formula, so using this we can find the density that is required in the question. And the next is a diesel engine has a compression ratio of 15.5 to 1 and a clearance volume of 9 cubic centimeter. What is the total volume of the cylinder? So we have the formula that is clearance volume is equal to total volume by volume of cylinder. So clearance volume is equal to total volume by the volume of cylinder, and total volume is given by swept volume plus clearance volume by, this is, sorry I just read it wrong, this is not the formula for the clearance volume, this is the formula for compression ratio. The formula for compression ratio is total volume by clearance volume, and the total volume is given by swept volume plus clearance volume. So just remember this formula, it can be helpful in other questions as well. So now this is we are having, it is given the compression ratio is given 15.5. So we have the compression ratio here 15.5, then total volume we have to find out, and then clearance volume. So clearance volume is given 9 cubic centimeter. When the clearance volume is given, we can find the total volume. Just remember this compression ratio is equal to total volume of the cylinder by clearance volume, and we can write total volume as the swept volume plus the clearance volume. And for the section B, we have made a separate video for the special ability questions, numerical ability and logical reasoning. So please go through these sections, and we have made videos of these sections which have been repeatedly asked in the synergy exam. And please go through this playlist in our channel for these sections. You can find this video which has been published in recent times as well, and for the previous year also we have made certain videos. So go through those videos also for the special numerical and logical reasoning. It will be helpful, and all the best for your exam. Thank you.